Our goal is to design a mechanism using two links that allow the intake to be parked in one position and deployed in another. The question is, how long are these links and where do they attach to the robot? Here's a geometric design technique that I find useful in describing all the possible solutions. First, let's decide where the intake is when parked. And deployed. I'll label each point A and B so they don't get confused. Now, if I were to choose some arbitrary link to connect point A, I know that the pivot point from that link would be the intersection of these two arcs. Here. If I draw lines between the pivot, the parked position, and the deployed position, then I will have an isosceles triangle. We can then bisect the line between the parked and deployed positions. And draw a line between the midpoint of the pivot. Because we started with an isosceles triangle, this produces two congruent right triangles. But most importantly, the line here is perpendicular to the line between the parked and deployed positions. The cool thing is that we can work this logic in reverse and say that the pivot for every link will fall on the perpendicular bisector of the line drawn between the parked and deployed positions. And in this way, in order to design a two-link mechanism, you just need to draw a line between the parked and deployed positions, bisect that line, and choose where on that line to put the pivot. Now, I will arbitrarily choose a couple points. Here, and here. Boop! Then we can assemble it all. And see that we get the parked and deployed positions we wanted.